All right, in this video, I'm going to generate the double angle identities. We're going to start with the sum and difference identities. We're going to start with sine and the sine sum identity. So remember, the sine sum identity says sine of alpha plus beta is sine of alpha cosine beta plus cosine alpha sine beta. Now what I'm going to do is I'm going to substitute alpha for beta. So now I'm going to have sine alpha plus alpha. So that is sine alpha cosine alpha plus cosine alpha sine alpha. Well, sine alpha times cosine alpha is the same thing as cosine alpha sine alpha because of the commutative property, and so we actually have two of them. So sine of 2 alpha is equal to 2 sine alpha cosine alpha. Now, for the tangent identity, we're going to again start with the tangent sum identity, where we have the tangent of alpha plus beta is tangent alpha plus tangent beta over 1 minus tangent alpha times tangent beta. And again, I'm going to substitute alpha for beta. So then I'm going to end up with tangent of alpha plus alpha. So that'll be tangent of alpha plus tangent of beta. Notice that all I'm really doing here is I'm substituting all my betas with alphas. Tangent alpha, tangent alpha. So in the numerator, tangent alpha plus tangent alpha is 2 tangent alpha. And in the denominator, tangent alpha times tangent alpha is tangent squared alpha. And this is the tangent double angle identity. That tangent of 2 alpha is 2 tangent alpha over 1 minus tangent squared alpha. All right, and finally, we're going to do the cosine double angle identity. And again, remind you about the cosine sum identity, cosine alpha cosine beta minus sine alpha sine beta. And you can probably guess that we are going to substitute alpha for beta. So we're going to have cosine alpha plus alpha. So that's equal to cosine alpha cosine alpha minus sine alpha sine alpha, which is cosine squared alpha minus sine squared alpha, which is equal to cosine of 2 alpha. But wait, there's more. Remember the Pythagorean identity that cosine squared plus sine squared is equal to 1, which means that I can substitute the cosine squared alpha here with 1 minus sine squared. So I'm going to now have cosine of 2 alpha is going to be 1 minus sine squared alpha minus sine squared alpha. So again, I substituted this cosine squared alpha with 1 minus sine squared alpha because of the Pythagorean identity. And now negative sine squared alpha minus sine squared alpha is going to be 1 minus 2 sine squared alpha. So this is another version of the cosine double angle identity. But wait, there's more. Now I'm going to go back to the original cosine double angle identity, cosine squared minus sine squared. And this time I'm going to substitute sine squared with, you guessed it, 1 minus cosine squared from the Pythagorean identity. So I have cosine of 2 alpha is going to be cosine squared alpha minus, open my parenthesis there, got to be careful with that, 1 minus cosine squared alpha. So that becomes cosine squared alpha minus 1 plus cosine squared alpha. And look at that, cosine squared plus cosine squared is 2 cosine squared. So we have 2 cosine squared alpha minus 1 is cosine of 2 alpha. So the cosine double angle identity is unique in that there are 3 different versions of it, and you can use whichever one you want depending on your situation.